As Ruchi mentioned, if you have any question, just feel free to use Q&A window or just unmute yourself after I will be finished with my deck and ask the questions live. With that, let us get started. I will be talking today about how you can take the best out of your cloud services, right? Even if the topic says VMware Cloud on AWS, a lot of nuances, a lot of performance optimization things that we are going to discuss, they will be applicable to most of VMware Cloud platform if the underlying storage is vSAN. So vSAN is the key for a lot of the things that we are going to discuss, right? So if you are running traditional storage, it's a little bit different beast from what we call VMware Cloud integrated, meaning combining NSX, vSphere, and vSAN. With that, let us take a look. And one again, all of my example and also live demo that I'm going to do at the end of our session today, we will be using VMware Cloud on AWS just because that is the product that I support, that my team supports. And I think that's our flagship cloud product, bringing a lot of innovation to the way how VMware handles a lot of things, including lifecycle management. So with that, let us get started with a simple agenda. We are first going to take a look at what we can do at VMware Cloud on AWS to optimize performance. Then we will switch to a demo where I can just go through some of the settings, and we will summarize the things that you learned today. Just to recap, and I hope most of you folks on the call are aware about all of the things happening, VMware Cloud on AWS is a product supported, delivered, and operated by VMware. That is the primary difference between all other hyperscalers offering, right? VMware owns the product, meaning it's our own solution. We are developing it, and you will see it's a number of nuances that exist between VMware Cloud on AWS and other hyperscalers, and even your on-premises vSphere implementation. The good thing, we have everything packaged together, vSphere, vSAN, NSX. We have it bundled, and we are managing lifecycle management for you. And as we are deploying on top of bare metal AWS host, you have access to native AWS services, and we do support workload portability and operation efficiency. With that, let us take a look what is under the hood, right? Because we are talking today not about why you would like to choose VMware Cloud on AWS, but rather how you can take out the best of the platform that you choose to deploy your cloud application. First and foremost, it's already 1 year as we announce and introduce a new host type. Our default SDDC right now is using i5.metal host, and that's a really powerful beast, right? We have 64 physical cores with one of the latest Intel Ice Lake processor with 1 terabyte of memory and 20 terabyte of NVMe disk. So meaning you can run literally, I wouldn't say each and every workload, it's still, it's still some limits. However, for 95% of your workload, you are running on your own premises vSphere. i5 would be perfect fit in terms of CPU capacity, CPU performance, CPU capabilities, memory capacity, and vSAN storage associated with that host. We still support i3 and i3N, as you can indicate on this slide. i3 is end of sale. i3N, we still continue supporting this host type. It's actually not bad, right? It's provided with a massive storage, still doubles the storage compared to i4i, right? And it's featuring Cascade Lake processor, also not, I would say, quite a good one, right? As for i3, I would encourage you all to consider migrating out of i3. Broadwell processor are pretty late. They are known to be subject of Intel vulnerabilities, and that's why we are disabling hyperthreading on Indoxion, so on Broadwell. And if you would have a chance, I would recommend you to consider our I4I conversion service to migrate your SDDC from i3 to I4I. From storage perspective, right? So as mentioned, we more or less the same thing, right? We are featuring on i3, that is the lowest storage that we have. On i4I, on i3N, we have 45 terabyte of raw vSAN storage, and i4I is somewhere in the middle. And we also have a slightly different vSAN capabilities, right? So on all the modern CPU host type, we disable deduplication. And again, the main reason for that is actually performance, right? So right now, looking at more than a number of SDDCs deployed on VMware Cloud on AWS, we see deduplication bringing some unnecessary performance hits to workload. We decided to disable it cluster-wide, and using vSAN original storage architecture, it's no way for you to control the settings, right? So the way how they are configured, how you see them on the slide right now, that is how you're going to use them. And it's important, right? So moving from i3 to i3N would not only give you better CPU type, but also would give you better disk performance, just because we're not doing the duplication. From other side, for some workload type, for example, for VDI workload, lack of deduplication might affect your capacity estimate. Okay, as we start talking about storage, what is important and what I would like to highlight, we recently introduced external storage support for VMware Cloud on AWS. And that is, to be honest, it's really a great thing, right? Because not each and every application require you to run on vSAN storage. And vSAN storage could be pretty expensive, as we're required to add host to add additional capacity to your cluster, right? So external storage would bring you an ability to deploy your storage intensive workloads using different storage types. But now the question is, what are my options if I'm looking, for example, to virtualize or to run in the cloud a large SQL server or a large Oracle database? What is the difference between external NFS data store, vSAN data store, or, for example, in-guest FSX options, right? This is important design choices, right? And as always, we have on one hand, we have costs, on other hands, we have performance, and we have capacity somewhere in between. And at the end of the day, we need to make something that would work for our application, will work for our user state, but still business owner are going to approve it, right? So understanding performance patterns of different storage solutions is a key for you to use your VMware Cloud on AWS SDDC efficiently. So in terms of performance, I would say very roughly, when we'll be looking at 4 different types: vSAN, FSX for NetApp ONTAP as NFS data store, flex storage, and FSX for NetApp ONTAP as in-guest mount. From performance perspective, we will be seeing the best performance provided by local vSAN on NVMe disk, followed by FSX for NetApp ONTAP, then flex storage, and then FSX for NetApp ONTAP running in guest. You might ask, why is the difference between FSX for NetApp ONTAP as an NFS data store compared to FSX for NetApp ONTAP as an in-guest mount? The major difference is, for this particular use case, for FSXN as a guest mount, this traffic will need to traverse NSX edge. And NSX edge, as you know, NSX edges, it's just a pair of VMs. Those VMs has own configuration limits, right? And if you have a number of other VMs consuming FSX for NetApp ONTAP through in-guest mount, all this traffic will flow through edges. Edges are fine to support normal north-south network traffic. They've never been designed to support storage traffic. And that is what we did by moving FSX for NetApp ONTAP volume as an NFS data store. because when you mount it as an NFS data store, you will be using ESXi interfaces, and ESXi interfaces will have an ability to bypass edge connectivity by providing you direct line to either VTGV or VPC pairing, and VPC pairing as a new feature coming with 124 release of VMware Cloud on AWS. So one again, it's a lot of options. How you would select them, how you would use them depends on the application. So for example, for SQL Server, like if you really want to go with price optimized configuration, you would like to have temp DB and transaction log located on vSAN VMDK. Your data could potentially go to FSX for NetApp ONTAP, better as an NFS data store or as a mount from FSX or NetApp ONTAP in guest, right? It would require some kind of partially different storage management. However, that would provide you this best mix of better performance compared with better cost. But again, depending on the size of the database. If you, for example, looking to run some archive solution, Flex Storage will be your optimal choice, right? Just because Flex Storage provides you a lot of capacity with literally lowest cost possible out of all four solutions we discussed. So it's always, as I'm talking about it, it's always a question of trade-offs, right? You cannot get anything, like you cannot get a feature for free and then use it and have no obstacles. So that's exactly the same. You will need to find the balance between cost, performance, and optimal configuration for your SDDC. And that is the beauty of architecture work, right? So even if you're taking a lot of burden of pre-creating SDDC, managing lifecycle for you, it's a lot of things that are still cloud architects must do to make sure that the SDDC works as expected. Okay, moving further. As you know, we support a unique feature. We support stretch cluster on top of VMware Cloud on AWS SDDC. Why it's a unique feature? If you would look at the way how AWS applications are designed, you will see you will need to provide the redundancy, right? You are not going to run your business critical application using just a single EC2 instance. Just because EC2 instance tends to fail, and AWS is not going to conspirate it or make any statement about it. They all know your EC2 instance may have quite a big chance to fail. So in order to tolerate EC2 instance fail, AZ fail, AZ, which is basically data center within AWS region, or AWS region fail, you will need to build a pretty comprehensive solution using multiple EC2 instances, load balancers, different replication between your databases, right? It's a quite comprehensive solution to build on EC2. VMware were always leading development in the infrastructure piece, meaning we would provide you redundancy using infrastructure level. And you can continue running on a single VM, and we will monitor and restart your VM even between data centers. That is what we can do with Stretch Cluster. And with our implementation on VMware Cloud on AWS, we can stretch vSAN cluster between two AWS availability zones, providing you AZ level redundancy. And that sounds great, right? But now let us go a little bit deeper and see what kind of performance implications such solution might have and what options we have to mitigate that. So as stated here, when a VM is looking to read some data from disk, this data is always available, right? Because we are using synchronous replication for each IO coming into the disk. And this data is always available, disregards on what side this VM is running. In terms of writes, that's quite different. So writes are always happening in the local AZ first on the local host. After that, host will initiate synchronous writes to another AZ. What does it mean? All write IOPS are going to cross AZ link. Is it good? Is it bad? I mean, that is how it's designed. In terms of your IO, for example, for heavy writes pattern with a small size of IO, it might have quite a huge effects in terms of performance. What's happening if we are looking, for example, at transaction lock writes? Transaction lock writes could be as small as 5012 bytes, really small one, and it will be a single IO in terms of vSAN. It's not a 64K IO, right? It really will be a small IO, sometimes like lower than 512 bytes. And we are sending an OLTP application could send 1 million of such IOPS at the same time, right? So it will be some delay because we need to cross AZ link, and it's just a distance, right? It's just a physics. No matter what, you need to cross the distance between your primary AZ and secondary AZ. And by the way, stretch cluster only provides redundancy between two AZs. It also requires a third AZ to be available in a particular AWS region, right? However, you cannot configure stretch cluster between 3 AZs, right? What does it mean for you? First of all, stretch cluster always replicate all writes using synchronous replication. So would it make sense to use database technology, like, for example, SQL Server Always On, that would replicate in real time all transactions, in addition to vSAN replicating all the traffic? You can do that. However, that would double the IO flowing across the same cross AZ link, probably hitting your performance one more time, right? Another thing is, what is happening if the whole AZ fails? My VM is going to restart in the surviving AZ. What is happening if I'm using any in-guest application recovery solution? I probably also replicating this traffic. And now I would have double replicated copy of my data. So the thing here, and one again, it's a lot of design choices. First of all, is to understand that stretch cluster might have some performance impact on your workload. You need to go and do performance test during your proof of concept. The next one, you need to think if you would like to replicate all VMs across two sites. It may be some VMs that don't require replication across sites. And even within VM, you can say that some VMDK does not require to be replicated. Like, for example, tempdb is going to be recreated upon restart. So we can create a simple script, detach VMDK, attach a new VMDK if it's an AZ failure happening, and mitigate having tempdb being located on a disk that will be synchronously replicated between two availability zones. And I see one question in the chat. Let me see here. Okay, yeah, thank you, Ruchi, for reminding folks to ask questions. It's actually a good point. If you see any content that you would like to have more details, or where you see it's not everything is clear, just let us know. Just use your chat or use Q&A window, and we would be happy to take those questions afterwards. Okay, moving forward. Let us now take a look at networking. Right, and networking is a key. When you're building your cloud environment, you definitely would like your user to be able to consume them. How that happens? Through network connection. So you will need to understand how network connection is happening within your SDDC to be able to plan for good performance for your application workload. So we have, I would say, two pieces that would build core networking of each and every SDDC. Tier 1 routers listed here would provide connectivity for management VM will stay apart from them, and compute VMs, your workload. Your workload is always attached to Tier 1 gateway. It could be your default compute gateway or could be custom tier ones or still tier ones. What does it mean? Those tier ones are running on ESXi host and tend to handle traffic locally within ESXi host. But what is happening if my VM residing on default T1 or custom CGV would like to access destination on premises, on the internet, reach out to workload deployed in the connected VPC? In this case, we will traverse tier 0. Tier 0 is different from tier 1. The major difference is with tier 0 is actually running partly on ESXi host, but mostly on a pair of VM NSX edges. NSX edge is just a VM, right? And what is happening now, you have thousands of VM possibly residing here and there, and all of this network traffic going north-south direction would traverse NSX edges. So you need to plan for the amount of traffic you are looking to get into your SDDC, including on premises. This traffic will need to be handled by your edges. If performance of your edges is a concern, take a look at large edges deployment. For that one, you would require at least 6 nodes SDDC. Right, but one again, that's the key, because edge network performance would actually define your network performance going forward. Very important point, sometimes we tend to forget about it, and we will talk about a number of other items. Okay, so now let us take a look at some settings that are user controlled, right? So most of configurations that I discussed before, those are the settings that are either pre-configured or those are the defaults. You can change them. You just need to know how those applications are configured. But now let us switch to some in-guest VM settings. Those VM settings are in your direct control, and some of them may have a drastic impact on the way how your VM performs. So we will go through most of common pieces, like let us start with virtual CPU. Virtual CPU, those are the CPUs assigned to your VM, not the host vCPUs, right? So what we would like to do, we would like to disable CPU hot plug, mostly because hot plug has performance implication. And also, like what I need to say, if you have a small VM, 2 to 3 vCPUs, 2 to 4 vCPUs, you can run CPU hot plug, no issues with that, right? However, if you are looking to run a VM with 64 vCPU on an i5 host, enabling CPU hot plug might affect the performance up to 5%, depending on how intensive your CPU, your application is in terms of consuming CPU resources. The next one, and during a live demo, I will spend some time looking at those settings. What we recommend is to match the way how you present vCPUs to your VM to the way how your underlying host is configured. As you all know, we are now exposing vSocket and vCores. What does it mean? Number of your vSocket should not be more than the actual number of physical socket you have on your host. So to make it simple, on VMware Cloud on AWS, all hosts have maximum of 2 sockets. What does it mean for your VM configuration? It should have a max of 2 vSocket. Everything else should be assigned as vCores. And for sure, you need to look at reservation and limits, right? So those are the things, if set not correctly, especially limits, they may affect your performance. So you will continue increasing number of CPU on your VMs. And basically your application would not be able to see that, right? Just because it's a limit imposed on number of CPU, of the amount of CPU resources your VM can control. From memory perspective, you can use hot plug, right? It has no impact on performance. We are doing it seamlessly on a backend. And for some application workload, we still would recommend to set reservation for memory. Just because a lot of processes are running on ESXi host, like not only ESXi itself, it's also NSX. it's vSAN, and sometimes you just want to make sure your VM has all the memory required for operating. For example, on a SQL server, you may think about reserving amount of memory that is equal to active data set of your SQL service instance. Or if you're running multi-instance configuration, you will look at active data set for all of your instances and reserve memory accordingly. Moving further, from networking perspective, VMX Net 3 is still our preferred and recommended network adapter. You may see that Windows VM might be deployed with E1000 or E1000E. That's mostly because VMX Net 3 drivers are not available by default with Windows OS. You will need to install them through VMware tools. However, deploying VMware tools is still an important part of your performance optimization, so I hope everyone would run VMware tools. So VMX Net 3 would provide you a way better control over different options to maximize network throughput for your VM. E1000E just limited to 1 gigabit per second. Even if your physical connection may say 10 gigabit, 100 gigabit, 75 gigabit, whatever else, E1000E would only give you 1 gigabit per second, right? While VMX Net 3 will give you physical line speed, and it could be even more if two VMs resides on a single ESXi host. We will be using internal ESXi host interfaces bypassing network drivers. From storage perspective, and storage, one again, storage is a key. We'll concentrate on the things that you're doing when running on vSAN. And with that, we still continue to recommend RAID 1 to be your default storage policy for application-intensive workload. I know that for more than 5 hosts, by default, you would recommend to use RAID 5 as a managed storage policy, or we'll switch to RAID 6. So switching to RAID 6 compared to RAID 1 is not a bad solution. It would provide you much more capacity with a slight effects on performance. However, it's you to define what you will consider a slight impact. RAID 1 will definitely be the best in terms of availability and performance. And obviously enough, RAID 0 is the quickest one. However, we don't support RAID 0 for any VM that you're considering as a business critical VM. You are looking to use as much control as possible. The way how vSAN works is really different from the way how on-premises storage array works. The major difference is for storage arrays, you have a dedicated storage controller. For vSAN, ESXi host is a storage controller on itself, right? So what is happening, we've seen that having multiple threads to different VMDK, to different objects on the vSAN would help to write more data. So if you will do a simple test and, for example, restore a SQL Server database and split VMDK between 4 PV-SCSI controller compared to a single one, you may see an increase 3x in the time just because we are able to have much more I/O threads back to physical disk. And the same is true for VMDK, right? So I have seen a number of times it could be VM running with just a single VMDK. You will have all your SQL Server database on the single VMDK, and we will let storage array to handle it. And it will do that, right? Because actually, storage array would cache most of your writes. And after caching, it will work directly with disk or disk rows to get them hardened on a disk level. It's just more or less a logical representation. On a vSAN level, one again, we have a limited amount of threads per VMDK. And if you have just a single VMDK, it's a good chance that you will be using all the threads. However, your SQL still has the data. So SQL Server would need to fetch the data and wouldn't be able to write the data on the right speed. So you will see some waits coming in your SQL Server. And with that, having multiple VMDK spread between multiple up to 4 PV-SCSI controllers, that is the best choice for your VM. And last but not the least, It's an important thing. And I have an example for SQL Server. It's also true for actually every workload. What is happening is the way how vSAN works on VMware Cloud on AWS. We are using 4K native NVMe disk, meaning physical disk format is 4K. VMDK presented by vSAN is always 512 bytes. That is what guest operating system would see. So when I would be running FSOTL on Linux or on Windows, I would see 512 bytes. However, on a physical disk, we'll operate with 4K drives. Why it's important? For some workloads, and for example, transaction log for both Oracle databases and SQL Server databases, SQL Server tries to optimize as much as possible through output of transaction log. That's why when SQL Server writes to transaction log, SQL Server bypass NTFS, which is interesting, right? So SQL Server has a way to bypass NTFS formatting, and it's really make no difference how you will format your drives in terms of NFS disk size. What really makes sense is your physical disk sector size, and that is what we have as 512. So what does it mean? All our transactions, all our IOPS will be now multiple of 512s. Would that fit into 4K? Not necessary. And what does it mean? We could have a situation of read modify writes where actually we would need to use a number of underlying physical sectors to write the same IO. That might degrade your performance, especially with small OLTP workloads. It may be up to 300% of degradation. So some applications have a way to work around it, some not. On SQL Server, the way to align your transaction log IO to underlying physical disk format is to use the trace flag 1800. With that, let me see if any questions. Okay. I have a question from Michal. I would like to ask you about performance of HVM north-south traffic. In case of, for example, IMEX packets pattern. During NFS explanation, you mentioned something that will be introduced in 124 about VPC peering. It's new to me. Okay, yeah, let me talk about a little bit about it, right? So the way how we build our networking on VMware Cloud on AWS is really interesting, right? So E6i host, physical host, has physical interfaces attached to physical AWS networking. And the same is happening with other instances, with other hardware running EC2 instances. What does it mean? E6i host has an ability to bypass virtual networking and just use physical connectivity to access some of AWS services. That is what we are doing for NFS traffic. So meaning we are not going through edges, rather we are going through the management interface of E6i host and mapping it directly to VPC containing FSX for NetApp. Sometimes we need to traverse VTGV just because that is the way how we connect two VPCs together. And in order to overcome that, right, you all know with NFS, with VTGV, it's a cost associated with running your traffic through VTGV, just because transit gateway, it's not only price per attachment, but also price per gigabyte by AWS side. So what we are doing, we are adding new options to pair with FSX for NetApp ONTAP using VPC peering technology. VPC peering technology has been introduced by AWS, I think 1.5 years ago, and it supports seamless network integration between two VPCs. It would require VMware SRE to help you with configuration. You cannot do it by your own. However, in this case, you do not need transit gateway, and you would not be in need to pay for additional cost. Now let me also talk about north-south performance. So for north-south performance, what is happening? We need to look at packets per second rate, right? That is the major counter that we would like to understand. And what we have, I can share you a couple of articles, performance articles after this call. What is happening, each edge has a limit of PPS a limit of PPS that we can support for each and every edge. Meaning, if your application produces more packets per second that edges can support, it will be queued or will be dropped, right? So that is the key things to look at the edge level. Hope that answers your question. Let me know if not, and I'm happy to repeat it. Okay, so with that one, let me see if I would be able to show you VMware Cloud on AWS SDDC and go through some VM optimization stuff. So just stay with me. I will be looking VM. So just give me a sec. See if I'm still logged in. I would. Okay, it looks like that it's actually work. So let me then stop sharing for a moment and then reshare the screen again. Okay, you should be able to see my screen and you should be able to see VMware Cloud on AWS SDDC, the latest one, 124, already using vSphere 8 update 2 really quickly, right? So really what we are doing, we incorporating the latest and greatest vSphere release with each new release of VMware Cloud on AWS SDDC. Right, so in order to discuss some of the settings we talked about, let me create a new VM on a cluster. Let me go here and say I would like to create a new VM just for sake of interested. We'll just go through the deployment visit very quickly. Let's call test VM as always, right? We'll be providing compute resource pool to run it. From storage perspective, you know that we have vSAN data store and workload data store, basically the same data store. Just vSAN data store is a logical representation for management cluster. So we're going to select workload data store, place it on vSAN. Compatibility is an important topic. It's basically defines hardware platform for your VM. And interestingly enough, you can see that we support ESX8 and later with the version 124, meaning we introduce hardware, virtual hardware 20 with all the good things virtual hardware 20 brings. And remember, virtual hardware is not only about limits, right? It's not only about how many CPUs you can assign. It's also, for example, adds CPU instruction support. Like, for example, if you're running on a ESXi 50 and later, and you're running on Intel Ice Lake processor, your VM wouldn't be able to use any advanced instruction of Intel Ice Lake, right? So always go with the latest compatibility version if you don't have any other applications that would not support it. In terms of supported OS, let us go and you'll see we support now Windows Server 2022 natively. And customized hardware, we'll skip this step probably at the moment, just because I will go into VM configuration. So let me now hit finish and see our VM being created. So we should be able to see it here. Okay, that's my VM. So now let me go and check the settings. Okay, so let us start with vCPUs, right? So we talked about in terms of number of vCPU assigned, I can go as high as 128. The reason for that, I have 64 physical cores. With 64 physical cores and hyperthreading enabled on Ice Lake, I can assign up to 128 CPU to a single VM, and I can have multiple VM with 128 CPUs. But now the thing is, what will be the best way how to configure that, right? And to be able to split your CPUs between different cores and socket, that is where you will see a different topology, right? And also that's an interesting thing, right? CPU topology with a version 124 vSphere update 2 and with virtual hardware 20, you can now have ESXi to control the way how we split your VM between how we split CPUs between your VM, right? And that's really, really a great step forward, because you don't need to think about vSockets, all other things. But if you're running on a lower version, you will need to go and I will take one of these VM and go through the settings to make sure we can talk about vSockets and vCores. Now let us take a look at memory, right? So from memory perspective, let us get something assigned. And reserving memory, you have two options. You can either go and reserve all guest memory, which is a good thing, right? Because now if I would change it to 450, reservation will fit to what I configured. If I don't use this option and I will go, for example, for 500, my reservation would stay intact. It still would be 450. Right, depending on what you would like to achieve, you can use one of these options. And memory hot plug, as mentioned, it would be fine if you will enable it. Now let us take a look at SCSI controllers. You can see it's also a huge step forward. We're now using VMware ParaVirtual as a default controller type for Windows VM on a Windows Server 2022. However, we have only a single controller. So for example, if I would like to add a new disk, let me do that, right? So I would like to have a new hard disk. So now we got a new hard disk. So let me change a little bit what we have in here. So let us say 120, just so that I would be able to differentiate between them. It's no new controller created. By default, it will be assigned to the same SCSI controller 0, and you can have up to 16 VMDK in a single controller. However, it's not the best thing. So what I would like to do is to go and add SCSI controller. So now as we have a new SCSI controller, we need to double check the type. It will be VMware ParaVirtual by default. And now I will need to go back to my disk and assign it to new created SCSI controller. It would not be, if you didn't hit OK between them, right, you wouldn't be seeing SCSI controller ID, because this ID is unassigned. You will be seeing as a new SCSI controller. By default, if I will be hitting add hard disk, it's always going to SCSI controller 0. Right, so every time when you're adding a new disk, you either would need to script it and assign it to new SCSI controller or to the SCSI controller of your choice, or you will need to change it manually. And last but not the least, let us take a look at network adapter, right? So network adapter, one again, with 124 and virtual 120, we switch to vMix Net Free as default for Windows Server 2022. If it's not the case, remember, you wouldn't be able to change the type, right? So when I do add and then select network adapter, let me scroll here. Should be seeing somewhere new network, right? So now I can change adapter type. But once I hit OK, the only way to change adapter type is to remove your adapter, clear your operating system, and then add a new one. So that's, I would say, key options I would like to highlight when configuring and running your VM on VMware Cloud on AWS. As mentioned, 124 with vSphere 8 Update 2 and Virtual Hardware 20 brought a lot of good things and a lot of automated configuration to VMware Cloud on AWS, right? So we're already seeing VMware ParaVirtual being default. We're already seeing vMix Net Free being default. We already see that on CPU side, you can control CPU topology, right? So that's really helps you to optimize your VM from the beginning. But it's still a number of items, especially from disk and storage controller, you would need to take to be able to leverage full capacity of your, or full performance capacity of your SDDC. And one more thing to add. When I hit on add new device, you probably seen we have now a number of controllers. And sometimes I'm getting questioned, what is the difference between SCSI controllers and NVMe controller? Would be NVMe controller a better choice for a vSAN running on NVMe disk? I would say in theory, yes. NVMe controller might be a better fit. However, right now, based on the performance investigation and performance test, we still see that SCSI controller of that VMware Paravirtual outperforms NVMe controller. So for now, our guideline stays the same. Stick with SCSI controller, select the type VMware Paravirtual, and do not use NVMe controller at the moment. We are working on making NVMe controller reliable, performing, and once it happens, we'll definitely change our recommendation. With that, let me pause and see if you would have any question. And in the meantime, let me see if I would be able to find a VM to show you. Yeah, so this VM might be a good fit. So let me see if CPU settings would be exposed here. You go and see. Yeah, so now if I was select 64 cores, I now have an option to define cores per socket. So if I define 64, I will go with a single socket, and that could be a right configuration. The other configuration you can do is 34 with 2 sockets. What you definitely don't want to do is one core with 64 sockets. Because, for example, SQL Server would think it's 64 separate sockets, and you cannot change layer-free cache between sockets, right? So that's the key thing that we would like to avoid, and that's why we introduce a new virtual hardware 20 capabilities, right? So just let us double check. This VM most probably would have ESX55, so it's just VM version 10, right? So that's why, for example, a good question to the audience would be why I only can assign 64 vCPUs, right? I cannot assign 128. The reason for that being ESXi55 and VM version 10 hardware compatibility. So if I would now go ahead and upgrade compatibility for your VM, which is basically very quick sync, right? So I will go with the latest one, which is an instant sync, right? So you see that right now my VM is changed to VM version 20 and ESXi8. So with that, now looking at my CPU configuration, it would be very different, right? So first of all, we would be seeing 128 cores because we support up to 512 CPUs. And also we have CPU topology assigned at power on, meaning ESXi will create right configuration in terms of cores per socket to run your workload. With that one, and I know that we close on top of the hour, let me know if any questions or any concerns or any feedback, or unmute yourself and ask a question live. And with that, thank you very much for attending this webinar today.